The Breeding Scheme Manager features a dedicated genotyping section where we can specify the use of different marker technologies throughout the breeding pipeline. This may include applications such as quality control, marker-assisted selection, and genomic selection. The stages where genotyping is utilized are already captured in the breeding population section, which gives us a general outline of the pipeline structure and activities. We will soon provide more details on the marker technologies applied, their purpose, and the number of markers used. Following the genotyping section, we move to marker-assisted selection, where we record the traits selected based on this approach and the number of available markers. In our example pipeline, we have markers for stem rust and glutenine, and we will document at which stage marker-assisted selection is applied for those two traits. Marker-assisted selection is highly efficient for traits that are difficult to assess reliably and consistently in the field, such as disease resistance. Some agronomic and phenological traits, on the other hand, can be effectively selected based on a quick and cheap visual screening. These traits are captured in the phenotype screening section, and we will use plant height and maturity as examples here. To add a new genotyping technology, click the plus icon. We create a low-density SNP assay for marker-assisted selection and choose a mid-density SNP array for genomic selection. After that, we specify the stage and application purpose by selecting the appropriate options from the drop-down menu. We document the use of a marker assay with 4 SNPs for marker-assisted selection at the F4 and a mid-density genotyping array with 3000 markers for genomic selection at the F5. If a marker technology is applied for multiple purposes at the same stage, you can add another application column by clicking the plus icon. Our marker-assisted selection activities in the F4 generation are detailed in the next section. We do this by choosing the relevant traits from our trait catalog and providing the number of markers available for each trait. 3 of the 4 markers are used for stem rust resistance. The other one is a GLU-D1 marker for glutenine. In the phenotype screening section, we focus on traits that are selected or culled through quick visual assessment rather than markers or an extensive collection and analysis of performance data. In our breeding pipeline, plant height and maturity are particularly well suited for this approach, as they are highly heritable and can easily be assessed during the bulk selection stages. We have already added plant height, and we will now include maturity. Similar to plant height, maturity is selected during the bulk selection stages based on single plant performance at a single location and replication in the field. Phenotypic screening provides the benefit of rapidly and efficiently reducing our population size by eliminating individuals that do not fit the desired performance range for plant height and maturity. This targeted approach helps us use our resources efficiently to focus on evaluating promising material for more complex traits in the following stages. In the following video, we will discuss how we capture the evaluation and selection of these more complex traits.